Turning moment diagram of four-stroke engine may be assumed for the sake of simplicity to be represented by four triangles in each stroke. The area of triangles are as follows. Suction stroke 5 into 10 power minus 5 meter squared. Compression stroke 21 multiplied by 10 power minus 5 meter squared. Expansion stroke 85 into 10 power minus 5 meter squared. Exhaust stroke 8 into 10 power minus 5 meter squared. So let me represent all these data in the given title. Each meter squared of area represent 14 mega newton of work. So 1 meter squared equal to 14 mega newton. I mean 10 into 10 power minus 6 meters newton meter. Assuming the resisting torque to be constant, we need to find the moment of inertia. So first we need to find moment of inertia of flywheel. So that is our first subdivision. To keep the speed between 98 rpm to 102 rpm, instead of average speed they have given maximum and minimum speed. So let me take minimum speed equal to n2, that is 98 rpm, maximum speed n1, 102 rpm. Find the size of the flywheel rim, I mean width and thickness of the flywheel, subjected to a given condition of density of the flywheel. So this is the density value 8150 kg meter cube. The allowable tensile stress tau is equal to 7.5 into 10 power 6 newton meter per square. So these are all the given constraint. Apart from that, the rim cross section is rectangle, then one side being 4 times the length of other. If you take a length, this should be 4 times of thickness. So a flywheel rim should be something like this. It will be shaped like this. When you cut this shape, you will get a rectangular shape. This is thickness, then 4 times of thickness. So this is the given condition. Here we need to find breadth and thickness b comma t for a flywheel. And let me draw the turning moment diagram. This is the turning moment diagram. Here the question itself 4 triangles given as 4 triangles. So I have drawn 4 triangle. Suction, compression, exhaust negative, expansion stroke only positive. Here our aim is to first find the value of I. So how do you find I? I equal to, so del E equal to I omega squared CS. To find del E, I need to find I need del E value. How do you find del E? So this is del E. We need to find the area of this portion. To find the area of this portion, I need T mean and T max. So let us see how to find all those parameters step by step. We need to find T mean, T max and DE. Then only I can find del E. So why should I calculate del E? Once I find del E, then only I can find I. So after that we need to find B comma D value. So this is the flow of solving this problem. So with this detail, now we will move on to next step. So this is the turning moment diagram of given problem. First we will find the net area of this diagram. So net area equal to A3 positive, then all the terms are negative, A1, A2, A4 all negative. That's why net area equal to A3 minus A1 minus A2 minus A4. So A3 81 something, and then all the remaining data. You just refer the previous slide. A3 85, then all the remaining data are here. You subtract 85 with these data, you will get 51 into 10 power minus 5 meter squared. We know that 1 meter squared equal to 14 into 10 power 6 Newton meter. So multiply these two parameters. So the net area is nothing but work done per cycle. So net area equal to work done per cycle equal to 51 into 10 power minus 5 multiplied by 14 into 10 power 6. Once you multiply this term with this term, this meter square replaced by Newton meter. When you multiply these two terms, you will get 7140 Newton meter. So this is the work done per cycle. So what is the formula for work done? Work done equal to T mean into theta. Here theta represent maximum angle 4 pi. So I can take 7140 Newton meter as T mean into theta. Here maximum value of theta 4 pi. From that I can find T mean value 7140 divided by 4 pi. You will get 568 Newton meter. This is nothing but T mean value. So this is T mean 568 Newton meter. Now I need T max value. So how do you find T max value? Take the area of this triangle ABC. For that, this triangle ABC is nothing but area of expansion stroke, work done during expansion stroke. So that is equal to half into height of this triangle AG multiplied by width of the triangle BC. So half into BC into AG. Then the work done during the expansion stroke, this is the work done during the expansion stroke, 85 into 10 power minus 5. Here the value is meter per second square, meter square. So that I need to convert into Newton meter. So multiply that value with 14 into 10 power 6. That is equal to half into BC value. Here B 2 pi, C 3 pi, then BC equal to pi. Then AG, that is the value I need to find, T max. So AG is nothing but T max. Now all the values are known except T max. Now rearrange all the term. When you reduce all these terms, you will get AG equal to 7575 Newton meter. This is 7575 Newton meter. Now I can find AF value. So what is AF? FG 568, AG 7575 Newton meter. Then AF is nothing but 7575 Newton meter minus 568 Newton meter. That's what I have written here. AF equal to AG minus FG. You will get 7007 Newton meter. So this is the value of height of the this triangle hatched portion. Now to find the area of this triangle, I need DE value, but DE unknown, BC known. So I'm going to use the ratio of triangle. Let me erase everything. The ratio of triangle means you have two isosceles triangles, A, D, E, B, C. ADE triangle 1, ABC triangle 2. So now I'm going to use ratio of triangle DE divided by BC. Base of the smaller triangle divided by base of the larger triangle equal to height of the smaller triangle divided by height of the larger triangle. DE divided by BC equal to AF divided by AG. This is AF, this is AG. Again AF 7007, AG value 7575, then BC value pi, DE unknown. The value of DE is what we want. So DE equal to, reduce this, you will get 2.9 radian. Now we got DE value. Now I can find the area of this triangle. Area of this triangle half into DE into AF. Half into DE value 2.9, AF value 7007. So finally you will get DE del E as 10,160 Newton meter. So with this detail, now I can find I value. That is the answer for subdivision 1. Let me show you how to find I value. Before that, we will find there is a two term N1, N2. 102 RPM, then N2 98 RPM. From that we can find average speed. So 102 RPM plus 98 RPM divided by 2. You will get 100 RPM. This is the average speed. From that I can find omega, angular velocity. Omega equal to 2 pi n by 60. You will get 10.47 radian per seconds. So with these detail I can find CS. CS is not given, but we can find CS using N1, N2. CS equal to range of speed divided by average speed. N1 minus N2 divided by N. 102 minus 98 divided by 100. So that is equal to CS equal to 0.04. So with this detail, now I can find I value. What is the standard formula for I? Del E equal to I omega squared CS. Del E value known from the previous slide. Omega we have calculated in the previous slide. CS also known. Now I can find I. When you rearrange all those things, you will get an I value of 2317 kg meter square. Next, I'm going to find few other parameters like mass, breadth, thickness. For that I'm going to use this formula. Shear stress tau is equal to rho v square. Here v represent velocity, not volume. Tau value given, shear stress, allowable shear stress given, then density 8150, that is also given. From that I can find velocity. When you rearrange this velocity, you will get as 30.3 meter per second. So velocity equal to pi d n by 60. This is the standard formula for velocity. In that n also known, average speed, then pi d 60. So d unknown. So we need diameter. So diameter equal to apply all those parameters. Finally you will get diameter of 5.786 meter. So this is the value of diameter of flywheel. Now there is one more formula for del E. Del E equal to mv squared CS. So this formula obtained by rearranging this term. So del E equal to mv squared CS. Del E value known, V value known, velocity 30.3, sorry, velocity 10.47, then CS value 0.04. From that you will get m value. So this is the value of m, I mean mass of the flywheel. Now we need the dimension of the flywheel, that is breadth and thickness. Let's see how to find breadth and thickness. There is a standard formula, mass equal to rho v. Here v represent volume, density into volume, then volume equal to pi dA. So here you will may get a confusion. So how volume equal to pi dA? This is how the flywheel looks like. Shape of the flywheel. You just cut this portion, you will get a rectangle. Breadth and thickness you take. So this is called area. Then this area multiplied by circumference, you will get volume. So this is in another way. So circumference 2 pi r, that I can take it as pi d. So that's why pi dA represent volume of this portion. Okay, then area equal to B into D. So pi into D into P into D into density. Mass known, so just substitute this mass value here. Pi into D value known 5.786. Then the breadth value already given, 4 times of thickness. So that's why I am taking 4t here, then again t, then density 8150. From that I can get t value. Then what is B? B equal to 4 times of thickness, just multiply this thickness with 4, you will get breadth value. So this is how you can find all the dimensions of flywheel: breadth, thickness, mass, moment of inertia, all these parameters. So this is how we can easily solve this problem. Don't forget to post your questions in the comment box. You can also mention the topics which you expect from my channel. Subscribe my channel and like my video to support my video lecture.